Hello, good afternoon.
Good afternoon, ma'am.
Yeah. So, did you all write that question? Have you all got the output for that? Were you all able to predict the salary with the years of experience using linear regression? Simple linear regression. Okay. I can't share screen.
Wait a second, ma'am.
Okay.
Ma'am, I have enabled it.
Yeah. So today we will be starting with the next type of linear regression, which is multiple linear regression. So in multiple linear regression, you will have multiple independent variables and one dependent variable, unlike in simple regression. So multiple linear regression is an extension of simple linear regression, as it takes more than one predictor variable to predict the response variable. In multiple linear regression, the target variable is a linear combination of multiple predictor variables x1, x2, x3. Like suppose if we are, if I have to just the data set example which we seen in the last session, that if I want to predict whether a person will purchase a particular item or not. So there can be multiple factors, right? Gender, it depends on the gender also, if that particular product is associated with the particular gender. Interest, then age can be a factor, then we can have salary a factor. Like suppose if I want to see whether a person will buy a car or buy a video game, so there are multiple factors, right? So if we buying a car means we will see whether it is a person, what age is the person, what is their salary. If these are like related to the product, then only we can say that the person will buy the product or not. Suppose if I have to predict whether a person will buy the car, so what can be the factors? Gender, age, salary can be the factor, right? Similarly for video game also, gender, age, and if it is a girl or a female, it will having less chance of buying a video game. Sometimes age can also be a factor. If a person, if a boy is of higher age, then they will not buy that video game. And salary is again, so we are just going to see that which particular variable has the highest uh, association with the output variable. So the equation of multiple linear regression is this: y equals to mx1 plus mx2 plus mx3 plus b, where x1, x2, x3 are the independent variables. M and b remains the same thing. M is the slope and b is a constant. Okay. So now we are going to see an example where we will implement multiple linear regression. So we have data set of 50 startup companies. This data set contains 5 main information: R&D spend, administration spend, marketing spend, state and profit for a financial year. So our goal is to create a model that can easily determine which company has a maximum profit and which is the most affecting factor for the profit of a company. Okay, so since we need to find the profit, so it is the dependent variable and the other 4 variables are independent. So the below are the steps for deploying the machine learning model. First, we will do pre-processing. Second, we will fit the model to the training set. Third, we will predict the result of the test set. So first of all, you need the data, which then you will download it. Yeah, so this is the data set. I will send the link. You all can download this. Let me know when you all are done with the downloading. Downloaded?
Yes, ma'am.
Okay. Okay, so let's import the libraries. And we will read the data. So what is the name of your files?
50 startup.
What?
50_startup.
Okay, mine is data 50. Okay, let me know if this is similar to what you have. Is it similar?
Yes, ma'am, same.
Okay. This column I have to draw. Have you all imported this data set? Okay, done.
Yes, ma'am.
So now we will extract the independent and dependent data. So what is independent data? All these are independent, right? So we will take it in the x variable, x equals to df of. So starting from 0 till 0, 1, 2, 3, till 4 we will take. sorry, df.ilog. So we are getting this, right? Now, if you see, we have a string column here. This we will be removing. Encoding. Okay, first let's get the data, extract the data. Then we have profit. Profit is there. So profit is at index 4. One minute. Why it's giving this in profit? Yeah, fine. Why so less values are coming here?
Ma'am, all rows.
Okay, yeah. So let me know when you're done till here.
Do we need the state also?
Yeah, we need it. Because it is multiple linear regression, so we are considering all the independent variables. State can also be a factor, right?
Yes.
Okay, done with this. Now what we will do, we have to encode the values of this state column. So again, we will import the label encoder library from sklearn dot preprocessing import label encoder, and we need one hot encoder also. So you will create the object of label encoder first. Same thing which we have done last time. Okay, now which column we have to transform? Which column we have to transform into this 0 in a dummy variable? Column number is 0, 1, 2, 3, third column. Or all rows of third column, you can do like this also. Fit underscore transform can be done at the same time itself. Okay, like this. Now, as I told you, we don't want any kind of relationship with each other in these categories. So what we will do is we will use one hot encoder. So we can create the object of one hot encoder like this, equals to, we can do previously that previous way also, or this way, categorical features is this. Okay, I think this is not in use right now. It's deprecated. So we will use the previous way only. Okay. What were we doing? This part we have done right. Now we have to import one more library from. Actually, I have to apply on a single column, right? Other columns should not be touched. So for that only, one hot encoder actually had this argument categorical features, but now it is not working. So that is the reason we have to use this library called column transformer. Okay, from sklearn compose import column transformer. So inside column transformer only we will first pass the name. This can be any name. We can give state, comma, one hot in, you will instantiate this class one hot encoder. Okay, and then you will pass the index. And then the same thing, remainder equals to pass through. Now you will use your independent variable to fit and
Ma'am,
trans.
can you just wait 1 minute? Ma'am?
Okay. Done. Now we will do fit underscore transform x. Okay, we have to put this inside one parenthesis. One hot encoder is used to create dummy variables. And it is used to remove the problem of having relational order, like to make these dummy variables independent. They are not related in any way. So that is why we are using one hot encoder. Okay, now if we will see our independent data, it is like this. Okay, if one is one country is there, others are absent, like that. Earlier, how it was looking? If I put 1 minute. Okay, now it is done. So now it will just show like this only. Yeah, now it's already transformed. Okay, so this is the way we will, when we didn't apply this, it was showing 0, 1, 2 for each particular country, state. But when I applied one hot encoder, what happened is it has removed the relation between each other. I think by mistake I have run that. I will again start from beginning. Now see, it's giving 0, 1, 2 for each state. When I applied this, then it has removed the relational. Now it's like this. So you all have done till here. Now there is a problem in this. When we have a lot of dummy variables, it might create a dummy variable trap. So we should try to remove one of the dummy variables. So how can we remove one of them is, we can remove the first column, comma 1, colon. We can write like this, right? The thing is that we should not use all the dummy variables at the same time. It must be one less than the total number of dummy variables. Otherwise, it will create a dummy variable trap. So if you have 3 categories, you should use only 2 dummy variables at the same time.
Excuse me, ma'am.
Yeah.
It's not showing the array for me. It's
What
showing
it is
like
showing?
50 into 53 sparse matrix.
Actually, yeah, you might have done this. You might have run this cell again, right?
Yeah.
So that's why this problem is coming. Try to again rerun all the cells from the starting.
Okay.
What is okay? Why can't we use all the dummy variables? Because the reason it will create multi-collinearity. Multi-collinearity is actually the occurrence of high intercorrelations among 2 or more independent variables in a multiple regression algorithm. Okay. We cannot put high correlation, like the intercorrelation between each one of them will become very high. So that is why we are removing one dummy variable. So have you all done till here? Yes or no?
Yes, ma'am.
Now we are going to split our data set. sorry, sklearn.model selection. So we have splitted our data set into training and testing.
Excuse me, ma'am.
Yeah,
Why we put value of random state 0?
yeah, I told yesterday, no, that when every time when we try to get a predicted output from the algorithm, the values will always change. When you don't want the value to change, it should be fixed every time. Then in that case, we use random state.
Okay, now why state equals 0? 0 value.
It's actually zero. It can be, see, it takes some values 0, 42. Usually it takes these two values.
Okay.
Yeah. We can pass 42 as well. Okay, done. Have you splitted the data set? Yes. Still doing? Hello.
Done, ma'am.
Now we will import the linear regression algorithm again, and then we are going to fit our data into that same algorithm. So from sklearn dot linear underscore model import linear regression. Then you will create the object of this. And then reg.fit pass the training data. So it has created a model. Done. Now you can get the predicted results also by using the test X test. So ypred also you can do, sorry, equals to reg dot predict. So this is giving all the predicted values. You can get the value of slope and intercept also here, like reg dot and reg dot so this actually giving multiple coefficients. The reason is that you have multiple variable values, right? That's why. You can also predict your value by passing some independent data here. So first, let's say I pass. Okay, if you want to see, let's try to compare this data set with the predicted data. Okay, you copy this. For this first row, what is the profit? Check in the data set for the first row. Profit is around something like this. So let's see how much is the variation among the predicted profit and the actual profit. So we will copy this row. Or we can use the X test. 1 minute. So this is the profit, right? So which is this column? 1 minute. See, when I wrote ypred equals to reg dot predict, it gave this same thing. You can do the same thing yourself also by passing the data for independent variables, and it will give the profit. Either you can get through reg dot predict X test, or you can pass the testing data and get the profit. You can also try to compare the values for actual data. Let me see that whether this is the first row or not in the data set. What is the New York's dummy value?
Two.
No, from this actually we have to use this pattern. One thing I can do is I will open this data set. Is this for New York? Is this for New York?
For the first data.
Yeah. Okay. So you have used this only, and that is what I New York is one, right?
Yes.
Okay. So okay, I forgot to write 0
Zero.
0.0.
Yeah, 0 and 1.
So this is giving the profit as this, and in this also you have somewhere around same kind of profit, right? So this is how you can compare. You can check the score also of your model. Reg dot score. First you check the score of training. So this means 95%. It is 89%. So when the model score is 95% with the training data, and with the testing data it is 89%. So this means that the model is 95% accurate with the training data set, and 93% accurate, sorry, 89% accurate with the testing data set. So we can also improve the performance of our model using some techniques.
And why there's a huge variation in training and testing? Like I got 95% and 93%. Like same formula we have applied, but why so
Did you
much
apply
variation?
random state?
Yes, ma'am.
Okay. Actually, it differs for everyone, but what was the random state value you
0, 0,
applied?
0.
Yeah, that is
Okay,
why.
ma'am.
See, when I applied random state as 0, it gave the different output for profit. Now it is giving 93%.
Okay.
Okay. You can also check for the graph, like you can check for the independent comparison, like which factor is having the most effective profit. So like suppose if I want to check the relationship between marketing, what are the column names? Administration spend between the profit, what is the relationship? R&D spend between the profit. How can we do this? We can plot them separately, right? Okay, we can use, what we can do for this data set is, because we have multiple independent variables, right? So what can we do is we can plot our data. We can plot the comparison of the data along with the actual data and the predicted data like this. So in Seaborn, we have a function called reg plot, which is used to plot a regression line between actual data and the predicted data. So I have stored y test, which is the actual data in X, and y pred, which is the predicted data in Y. You can use any other names here. Okay, I think I have to use X and Y only. Okay, this also can be done.
Ma'am, what exactly do the points signify? Because there are just like
The
10
actual
points.
data and the predicted data, like this is the predicted line. So the same thing it signifies here also, like we can just check how the model has predicted, whether it has predicted well or not. So points are the actual data and this is the predicted data, the line.
Okay.
Ma'am, for this multiple data, we can use only Seaborn for visualization.
Because we cannot plot multiple, if I want to plot multiple columns together, it will not be possible. That is why I have just used the actual and predicted comparison.
Okay, so Seaborn is like
We-
visualization for multiple.
No, not multiple. We can see, 1 minute. I will try to do the same thing. Yeah, actually, see, this is not fine. So that is why it's better to use Seaborn only. For multiple data, we can use this Seaborn.
Ma'am, it's multiple data, but we plot against actual data and the predicted data.
Yeah,
Then there is will be two columns, two data sets.
actually, it is taking all the columns of that actual data and all the columns of the predicted data in YPRED. I will tell that using for loop also, I will tell in the next class how we can plot it in using, matplot also, but there is actually a different way. So we need to use for loop in order to get all the columns. Actually, the problem is, no, when you plot a multiple linear regression graph, the dimension of the graph will also increase. So it's not possible to directly draw it inside the plt.plot function. That is why this Seaborn library is used. It already has this function which is able to tell you the comparison.
Now it's a combination of a scatter plot and a average line, right?
Yeah, reg plot, yeah.
Ma'am, that is the warning.
That it's telling to give the variables here, actually x and y. That is the warning it's showing. So I have to give a question on this also. And in the next session, I will tell if it is possible to plot all these columns together in a graph. We can try, I will just see that. And one more thing is we have to also see how we can like see this, how can we increase the score of our model, right? This score, if I want to increase, how can I increase it? There is one way called backward elimination technique. There is that technique to increase the score of a model. So that I will explain in the next session. Okay. Okay.
Okay, ma'am.
Yeah. Question, I think I need to see which question I can give in this. Otherwise, you can use this thing, like 1 minute. That time you have downloaded one data set, no? Which was having country also, age, gender, purchase data set. Do you all have that data set? No, sorry, that was a classification data. No, we cannot use that. Okay, I will share it through someone and then you will get the question. Okay, I will try to share it today.
Okay, ma'am.
Yeah. Okay. Thank you.
Thank you, ma'am.
Okay. Yeah.
Okay, ma'am.
Thank you, ma'am.
Okay.
Thank you.
Welcome.